Count the number of pair pairs. Given a zero-index array nums of size n and two integers lower and upper, return the number of fair pairs. A pair ij is fair if I is less than j is less than n, so I and j are probably the indices, and lower is less than or equal to nums. So the sum of the numbers at those indices is between the upper and lower bounds. So here nums is the set. So the number of pairs of numbers that add up to 3 to 6. 0, 0, 4, 0, 4, 0, 5, 1, 4, 1, 4, 1, 5. So 6 pairs. Okay. Seems simple enough. How to do this? So probably they want you to do something that is less than n squared, because n squared is pretty straightforward. So let's say kind of the slow n squared method. We'll just see how poorly that performs first. Using double for loops. So for every, let's say n is the length of numbers, for every index I in range n, for every index j in range I plus 1 to n, if the value at I plus the value at j is between the lower and upper bounds, answer increments by 1, answer initially is 0, and return the answer. Value. Nums at I, nums at j. Okay. Okay, it's probably timing out because it's too slow. Yeah, okay. Too slow, too slow. So how to make this faster? If we consider, I think sorting it is probably going to be the method here, because the sums are going to be, there's going to be like some something that we can use to leverage the fact that it's sorted. Like everything that's too big is going to be too big, and then everything after that might be ignored. So we'll say nums.sort. Okay, so if it's all sorted, right? So if the array was 0, 1, 4, 4, 5, 7, 1, 4, 4, 5, 7, then I think you can go through for every so if you so a trivial case would be if the lower bound is smaller than the two biggest ones. So if the lower bound is like 30 and your two biggest one is 5 and 7, you know that that can't work. Or if the upper bound is smaller than your two smallest. So if the upper bound was like 6 and your two smallest was 10 and 11, then that can work. But how to generalize that? So for every number, there's going to be, you might search, for every number you might search for the number in the, you might search for the number in the sorted array that could pair with it in terms of upper and lower. That would be n times log n, I think, because once you sort it, finding another value inside the array is going to be log n, and then for every value. So you could do that. So could go through each value, find the in sorted array, let's say v, and find lower minus v and upper minus v, which, so this should be like n times log n. Because n for searching everything. We're going through each value, and log n for finding other values. I wonder if I can do this linearly though. Well, even if you do it linearly, once you sort it, it's more n log n. So if I had 0, yeah. I think you still, oh, for each number, can I do this faster? 0, 1, 4, 4, 5, 7. So here you go. The values of numbers, okay, there's not really bounded, so you can't really make like a static frequency array. If this was like all numbers between 1 and 100 or something, you might be able to do that. So here, 1, 2, 5, 7, 9. The lower is 11, the upper is 11. And the lower and upper are pretty large as well. So there's n log n. Could I do like a heap? So if you pull out the, say you had a heap, take the smallest, you have a heap, you take out the smallest, alright, I'm just gonna try this method that I thought, the n log n here. So for every I in range n. Value 1 is going to be, let's say low val is going to be nums at I for every, and then you just search, right? So you say, say pair index 1 is going to be, you want to use bisect to find within an array some other value. Okay, so other low is going to be lower minus this low value. No, this doesn't make sense. Okay, say the value is nums at I. Other low is going to be the lower bound minus this value, and other high is going to be the upper bound, and that's inclusive, I want to say. And then you want to do, let's say index, index low is going to be bisect left, for this array nums, other low, and you can also give the parameters for the low and high indices. So I think you should say that the low index should be something that is higher than the current index, and the high index can be anything. Index high is going to be bisect left, nums, other high, also after this. I'm just trying to think about inclusivity. Is it going to be other low or other low minus 1? So it would search for the value, and it would find the left side index of the value. So for instance, let's say the lower is 4 here, and your value is 0, and your other low value would be 4. 0 plus 4 is 4. So it should do that correctly. It should find the correct index. But if your low value is like, if you're searching for, and let's say there's no 4s here, like if you're searching for a lower 4 and you have 0 here, and you have the bisect left is going to find where you would insert 4, and you would insert it here. That still works because 5 is still smaller than 4. Okay, so that's fine. And then bisect left for something big would also be fine. Okay, I think this is good. So answer plus equals the range of values between them. So index high minus index low, is it +1? I don't think so. I think it's actually just those. And return the answer. N is the length of nums. Okay. So let's just go ahead and print I value index high, index low, and index high minus low. Say what the answer is. Okay, so it's going through the first iteration. 0 is the index, 0 is the value. Index high is 5, index low is 2. I'll go and just print out nums here. So 0 should pair up with 4, 4, 5. So that's index 2 to 5. That's right. 1 should pair up index 4 through 5 as well. 1 should pair up. Oh, I see. The 1 doesn't pair up with the 5 because it's it would insert it after. So this should be index bisect right. Okay. Let's go ahead and just comment that out. Okay, 63%. There's something considerably faster. I wonder if I can use a heap. Heap is generally n log n, but like it's a little less than n log n. It's like n log size of the heap, where the size of the heap can be up to n, but often is less than it. Generally with these things, you should be able to do them with either heaps or full sorts. So if you have I wonder, can you, so as you increase your lower bound, as the value increases, the other value should be, your other value should change, should maybe use that for some knowledge. So for instance, if you have 0, 4, 4, 5, 7, 0, 1, 4, 4, 5, 7, if you pair the 0 with something that is 4, 4, 5, then you can pair the 1. 5 here has to be lower. When you pair the 1, it has to be at most 5. It can't be the 7 anymore. The lower bound is still, yeah, the lower bound, you pair the 0 with the 4, then you pair the 1 with something at least as big as 4. No? The lower bound must be lower. So if you pair the 0 with the 4, that's 4. Pair the 1, it can only be at most 4. It has to be, it can't be smaller than 4. So maybe you can use index low as a tool to narrow the range of the search on the second pass. And if you do 0 and 5 is your upper bound, then 5 is also your upper bound when you increase the lower value. Yeah, so I think that makes sense. So how to do that? So the other low starts out at 1, and the other high starts out as n. No, so this is talking about indices. Index low starts out at 1, and index high starts out at n. And then you change it here where you use something that is at least index low plus 1, and index high I think that makes sense. Okay, let's try it. No siree, did not make sense. Index low. Okay, let's go and print out what's going on here. So on the first pass, 0, I think maybe index high got too high. How did it go? Oh, index high is the starting index. I see. So index low to index high is used for both, I think. Okay, so it worked for one of the two cases. So what happened here? So sorted array is 0, 1, or 1, 2, 5, 7, 9. 1, 2, 5, 7, 9. So the first passage is index 0, 1, 1, the low paired value is going to be 10. The high paired value would be, well, actually the lower boundary, yeah, low paired value is 10, the high paired value is 10. So it finds 10, 10. It doesn't find 10, 10. Which makes sense. So it says that 10 would be placed after the 9, which is index 5. So the next pass does 2. 2 would be paired with 9. Okay, so what's the... So higher, the next value that's bigger, should lower the low bound. Should lower the low bound. Yeah, okay, so the low bound should be index low as the high point. And it can be anything up to that. So I plus 1 to that. And so what would that mean for the upper bound? The upper bound needs to have index high as the low point. index high is the low point. Yeah. Nope. Nope, 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 nope. So 0, 1, 1 pairs with 10. 10. So where is 10 going to be found? So initially index low should be very big, and index high should be 1 maybe? Still not right. So 0 has a value, index 0 has a value 1. So you're searching for 10. And that should be found, yeah, so you shouldn't find any. And the second time you're searching, you're looking using 2. You're searching for 9. 9 should be searched. The low value, the low index for 9 should be 4 is correct. 0, 1, 2, 3, 4, 9. Yeah, 4 is correct. This is not correct. So you should be searching for 9 where the index high. So you're using 10. Index high is currently what? Your index high is currently 5. So then it's saying 5 minus 4. This is kind of confusing in terms of printouts. Let's just be clear here. Index value indices. Okay, so value 0, you're going to pair values 1, you're going to pair it with 10. There's nothing to pair it with. Values 2, you're going to pair it with 9. Actually, that's right. 4 to 5. Because 4 to 5 would be those two. Values 5, you're going to pair it with 6. 6. And here, you don't find 6. So the answer should be, indices here should be 3, 3, 0, 1, 2. The answer is 3, 5. Your it should be I plus 1 to index high. Yeah, maybe it's I plus 1 to your index high. You're using your index high as your... Nope. Not even close. Okay, I plus 1 index high should be starting. Okay. See how this goes. Still the same speed. I don't think this print matters. Slightly faster, 72. Their way. So your other low value starts from your current value to your next low. Oh, I don't know. Heap way. Heap. So if you sort it, and then you add stuff to the heap. Pointer. Double pointer. So you have one pointer. You have one pointer for the current value, the current index. And then you have another pointer for the spot for your other low, and another pointer for your spot for your other high. And you move those, and as you increase the value, you can you would decrease your other low value index and decrease your other high value index, and you always go downwards. I think that would work. So okay, let's try that. So let's say I in range n, the value is number I. Other low values lower minus value, other high value is upper minus value. And I think you still want to do a search for the first time you do it, but maybe not. Maybe just start with I think doing a search makes sense. So maybe index low is the bisect left of nums and your initial thing. So it would be lower minus nums at 0. Starting index 1, going to index, starting index 1. Index high is bisect right, nums lower, nums upper minus nums 0. Also starting index 1. Okay. So for everything after that, in the general case, you're going to find your upper, you're kind of finding your other low by decreasing it until it's to decreasing it. So while what? Actually maybe this is not correct. So while value plus nums at index low is bigger than upper, or bigger than the lower bound, then index low minus equals 1. Is bigger than the lower bound and index low is not too low, it's bigger than does index low go bigger or smaller? Does index low go bigger or smaller? 5, 5, 3, 5, 4, 3, 4, 5. There's no actual logic for it. No consistent logic. Index low is the upper bound of the next index low. Really? Two, 3, 4, 5, 6. 5, 5, 3, 4, 5, 6. Okay, so if you're increasing your first number, the paired lower bound index should be increasing or decreasing? Paired lower bound index should be decreasing. Right? So you go from 0 to, let's say, 10. Then the previous thing that worked with 0 has to be smaller in order for it to work with 10. Like it can't be bigger in order for it to work with 10. It has to be small. Why do these indices not go downwards then? So 0 paired with 4, 1 paired with 4, 2 paired, it's, yeah, once it doesn't work, it doesn't work, right? Like, if the smallest number itself, Interesting. So if it's 0 and something large, 0 and 4, so there's a gap. But once there's no gap, then there's no gap. Interesting. Value plus nums. So I should say here that the index low is at so how does this work here? Index low is probably going to need to increment each time. So if you have while value plus nums at index low is greater than lower, and index low is greater than the actual index I, then you can decrement. And then you always want to increment index low at the end. Answer, okay, and then while value plus nums at index high is greater than higher, index high is greater than I, greater than index low. Index high should go down. And the answer increments by index high minus index low. And then I want to say here that you want to increment with index low and index high. Or you say that the minimum of, maybe you say here index low is at least I, or I plus 1. Index high is at least index, also I plus 1. Okay, I don't feel great about this. Value plus nums at index high greater than the upper bound. Okay. So we'll then just do some prints here. Print I, the value, index low, index high, answer. Zero has a value of 0. So it's searching for, actually let's go and just print. So start, answer, index low, index high. Okay, starting. Oh, okay. So for your start, 0 is your value, and you should be searching between indices 4 and 5. Indices 2 through 5. Which are, yeah. So 0, so 4 works, so it actually goes down to 1. 1 doesn't work. So I think this thing should be index low and index high should always be adjusted by 1. Because you always go too far. Okay, so 5 value plus index high. So 0 plus 5 is not bigger than 6. So it should have stopped. So why didn't it stop? And index high is greater than index low. Value plus nums at index high. Not sure why this is index high becomes 2. Nums at 5 is 0, 1, 2, 3. Nums at 5 is 7. Okay. 0, 1, 2, 3, 4, 5. Yeah. So it should go down by 1. And that point, nums at index high should be 5. And 0 plus 5 is not bigger than 6, so it should stop. So first pass, zero is the number, searching for 3, so that should be there, and then, the first pass was 0, 0, your index low is 2, and your index high is 2. So it didn't decrement the index high here. So why did index high become 2? Okay, index high plus 1. Oh, this thing became the minimum. No. The minimum of index high starts at 5. Start index low, index high. What is going on here? So the loop start is 2, 5. Let's go ahead, move it here. Okay, the loops. Oh, it's should be the max, not the min. Okay. While value plus nums index low is bigger than lower, and index low is greater than I. I can be n minus 1, and then plus 1 is n. Maybe it should be I then. Value plus nums at index low. Oh, I see. I think maybe this thing is off. No, it's not fair. Value plus nums at index low. Index low. Index low is at least I. Alright, let's go ahead and just print out that. What index is it crashing on? Loop start is 5. I see. Oh, it's just backwards. Is it backwards? So why does the start? So loop start is 5 because we're searching for 11, or you're searching for 10. 10 is out of bounds. Maybe this should be offset by 1 actually. While value plus nums at index low minus 1 is greater than or equal to lower, and index low is greater than I. So while at that point, yeah, okay, yeah. And then same thing here, index high minus 1 greater than equal to upper, while that number, I guess greater than upper. That number is still bigger than what your upper can be. Okay. Still out of bounds. Oh baby. That was a lot of trial and error. So let's say what is this doing here? So it goes 0. So that should pair with something that is 1 through 6. And that should pair with something that is index 1 through index 6. So that should be adding 5. So the start is 1 through 6, which is correct, and somehow it became 1 through 5. I think maybe it's index low minus 1 is greater than I. That should prevent this issue, because the lower bound is what's wrong. Still doesn't do it right. So what should we be doing? Should be doing 5 plus 4 plus 3 plus 2 plus 1. 5, 4, so that should get to 15. So it does 5 on the first go, and it does another 5 on the second go. Index low should be at least I plus 1. Okay, well I fixed this one and I crashed everything else. Let's go say at least I plus 1. Back to fixing. Oh boy. So index low is at least I plus 1. And then yeah, so it should be 0 and this should be 1, 6. 1, 6. Maybe I should be, I think the way to fix this might be just to start by incrementing the answer first. Because the answer is always correct at the start. No, that doesn't make sense. The answer is correct at the start of the very first loop, but not necessarily after that. Well, values at nums, value plus nums at index low minus 1 is greater than upper, and index low minus 1, index low is greater than I. Eventually it could be equal to I though. And index low minus I not equal to I. Index low minus 1 not equal to I. And index low could eventually equal I. If you look at the one before that, index low minus 1, index low minus 1 is greater than I. Alright, let's go back to index low is at least, index low should be at least I plus 1. Yeah, that's fine actually. So what's wrong with this? 0 is paired with 2 to 5. 1 is paired with 2 to 5 as well. 4 is paired with 3 to 3. 4 is paired with 4 to 3. Ah, interesting. I just need to increment the index high. Okay. Alright. Come on, buddy. Oh. Is there a point of no return? Is there a point where I can stop the loop? Right, if there was no range for the previous set, could I somehow say that it's not possible? Yeah, there has to be a shortcut here. I'm missing a basic shortcut. So 1 is paired with 2 to 5. 4 is paired with nothing. 4 is paired with nothing, and also 4's, and that nothing is like, that nothing has an index that is 1 above it. And that, yeah, so that means that the range value is just too small. Or there's like, you're pairing with something that is before it. So I think I can say something like, um, if index low, index high equals index low, and those values are 1 more than the current index, break. Yeah. Okay, that was a significant improvement. I wonder if I need this, to be honest. What if I don't have that? Fuck. So, what happened there? The first pass went 5, and then the second pass, second pass, index low has to increment, has to be at least I plus 1. Okay. Should I try to optimize this more? So if your lower bound is I, yeah, maybe you can say that lower bound is I. I wonder if you always increment your lower bound by 1 rather than using max. I wonder if that is better. Always increment your lower bound by 1. Next to your lower bound. Okay, I think that's good enough. There's probably some optimizations I'm missing. Alright, so what's going on here? Overall, I sorted the array. I kept track of the initial indices where you'd find the pairing for the first value in the array after you sort it. So after you sort like after you sort something like this, you look at 0, you need to pair it with 3 or 6. So you'd search through your sorted array to find where you would insert 3 on the left side or 6 on the right side, and that'll give you your initial range of fair pairs. And then for every later value, the low bound is going to be at least one more than the current index, and the index low can be you can start at where your previous index low was from the last pass, and then you just go backwards from that point as long as the condition is true that this value currently plus the the other low value is going to be bigger than the lower bound, so therefore you can decrease that spot. Similarly, the value plus the value at the high index is bigger than upper, then you should be able to go down. Alright, so this is sort the array to leverage sorted trait to quickly find pairs. Here, this is a double pointer technique. I think this is typically a double pointer. You have a pointer for one pointer for value. Technically, this is kind of a triple pointer. Other pointers for tracking where the other lower and upper indices are, and as you change value, in this case it increases the pointer to lower and upper should in general decrease with the caveat that it can't be smaller than I, as those values need to be adjusted downwards. And then there's some optimization for ending early when index, I wonder if I can say index high is equal to I plus 1. That should be good enough. Yeah. And cut out one condition in an if statement or whatever. For ending early, index I equals I plus 1. Time complexity, this is O of n log n for sorting, and O of n for double pointer technique. Because the while loops will never exceed n iterations, as while loops never executions. And then space complexity, this is O, O1, no extra arrays needed, although you did sort the array. In place sort. In place.